Good morning, everyone. Welcome back to math. Today, our topic is scientific notation. We're going to talk about what it is and why it is important. And then we're going to do some example problems so that you'll get really good at this. So let's think. Scientific notation? Well, it's sort of like doing abbreviations. And when you're writing and taking notes, when you kind of do a shorthand because you don't want to take time to write it all out, that's what I think about when I think about scientific notation. It's a way to write numbers that are really big and really small. And here's why. Think about in science. We spend a lot of time dealing with data and facts, numbers, gathering, and sometimes, we can come across some really huge numbers. For example, let's take a look at this number right here. This is the number of miles that it is from Earth to the closest star outside of our solar system. This is a really big number. So we always look at a lot of really small numbers too. So let's take a look at this small number. When you first look at this, it doesn't look very small, but it really is. And the reason why I know it's a small number is because that decimal point is right there. Now, this number is the amount of time that it takes for light to go from one side of an average sized bedroom to the other side. And that's probably about 30 feet, okay? And these numbers right here aren't even the biggest and smallest that we use. Now let's take a look at this number. This number is the amount, this number of atoms is an average size glass of water. And this number is the weight in pounds. Notice there's a decimal place here again. So it's really a tiny number. And this is the weight in pounds of a protein and an atom. Look at all those zeros, you guys. These zeros are such a pain, right? Just imagine having to multiply this number by this number or do division. If we do any of this by hand, it would be such a pain, even if you're using a calculator or a computer. Just typing in all those zeros and making sure that you haven't forgotten one or added it in a couple of more times than you needed to. Wow, what a pain. So scientific notation comes in handy because it lets us take numbers like these numbers and just try to make it a little bit more easy for us to do calculations with. So, remember, we need to try to get rid of all of the zeros and write them in a very compact and very simple way. That's much easier. So let me show you. So let's start. Take a look at this first number. I'm going to slide these down. And I want us to focus on this first number right here. So we're going to compress it down and write it in scientific notation. The first thing is we figure out where would the decimal place be. A lot of these numbers won't actually have a decimal place written, but you know that it should be right here.
Miss Heath,
Yes,
wouldn't you start at the end if it's a whole number?
absolutely you would start at the end. But before I start at the end of that whole number, I do want to make sure that everyone understands where I would need to stop when I started at the end. Where you need to remember that the coefficient is always going to be between 1 and 10, and you always need to leave one number, one digit to the left once you start to count backwards. So let's try it. So I'm going to start right here on my end, and I'm going to go in this direction to the left. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my decimal point is going to be right there between that 2 and that 5. My decimal point is going to be right there. Does everybody see what I did? Make sure, like I said, that the new spot that I moved or I stopped to is sitting right there. And it is only one number or one digit to the left. Only one number or one digit to the left. I should say one digit to the left of the decimal place. So the decimal place is here. And then there's one digit there. So how many times did I move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I moved 13 times. Went back and I moved 13 times. So now I moved it 13 spots in that direction. So I need to write the number with a decimal place in the new position. So it's going to be 2.53. And then I got to get rid of all of those zeros after this 3 here. So this is the first part of the number. Now I need to account for the fact that I moved the decimal place 13 spots. So I'm going to multiply by 10 to the 13th power. Does everybody understand that? I moved at 13 spots in this direction, going this way. So the 10 raised to the 13th power. You see this number right here? The exponent is the same number of spots that I moved. This is an exponent. And that 13 is the same number of spots that I moved. Now, let's try this second number right here. We're going to look at this one right here. Okay. Now, here's a very small number. Remember I told you when I saw that decimal, I knew that it was small? Well, I'm going to do the same thing, but instead of getting bigger, this exponent right here, that 13, which is an exponent in here, when I write this one, that exponent is going to get smaller. Let me show you what I mean. Decimal places will get smaller because we have to watch what direction we're moving in or moving the exponent in. So watch me as I move. Remember, I told you I'm going to always do I start here? Do I start at the end? Anyone?
No, ma'am.
No, you do not. When there's a decimal point, you're going to move to the right. When there's a decimal point, you're going to move to the right. So I'm going to mark my point here, and off we go. 1, 2, 3, 4, 5, 6, 7, 8. Why did I stop here? Why did I stop there?
Because your coefficient is going to be between 1 and 10.
Because the coefficients have to be between 1 and 10. Remember, through the power of 10, your coefficient is always going to be between the numbers 1 and 10. Now, the decimal place is going to be there, one digit. That's not a 0. We have to put it one digit that is not a 0 to the left of it. And there is one digit. Where's the one digit that's not a 0 to the left? The 2. The 2. So 1, 2, 3, right here. 1, 2, 3, 4, 5, 6, 7, 8. Okay? I have to move at 8 in this direction going this way. Remember, we went this way. And I moved 8 times. Okay? So it's going to be 2.0, and I'm going to write it like that, 2.0. There's my 2.0. And now to show that I moved the decimal place 8 spots, remember I moved it 8 spots in this position, I'm going to do 10 times 10 to the negative 8.
Miss Heath,
Yes.
wouldn't the coefficient be 2.03?
2.03 times 10 to the negative 8. That is correct. So, I move the decimal place in this direction and I get a positive number. So, when I said I get a positive number, I'm reminding you the difference in when you get positive and when you get negative. Notice right here, my exponent is positive. Notice here, my exponent is negative. So I've provided you with some rules. Here are the rules. When you're using that exponent, when you figure out what your exponent is going to be, if you moved left, this is left. If I move going back this way, okay? If I move left, then my exponent is going to go up. If I move right, that means going in this direction, such as when I did with the decimal. If I move right, my exponent is going to go down. Going down means negative. Does everybody get that? Make sure you're copying these notes. It is critical that you understand this right here, this particular rule. So you always have to rewrite your number. And then lastly, we'll do this one. I'm going to leave my little rule up here so you can remember what to do. I'm going to call on a volunteer to do this one right here. Talk to me. That's a really big number with a lot of zeros. What do I do?
You start at the very end.
I'm going to remember that is a whole number. I'm going to start at the very end, which means I'm going to go all the way down here. And now what do I need to do?
You're going to go to the left.
I'm going to move left. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Is this where I stop?
Yes, ma'am.
Yes. Remember I said you need to make sure you've got one digit right here to the left. Okay? So that's going to give me what? How do I write this?
3.06.
3.06 times 10
to the 25th.
to the 25th power. And it's positive. It's not negative. Okay? Remember, if it's left, then it goes up. And that's a higher exponent because we went left. I'm going to put my little arrow there to remind you that we started here and we moved left. Guys, I hope that you all learned something about scientific notation. In my next video, we will do some practice. Hope you have a good day. Bye.